Hello friends, now we are going to describe a program which converts a binary number to its decimal equivalent. That is, the user will supply a binary number in the form of some bits or containing ones and zeros, and that will be converted into its decimal equivalent. So this is the program which I have written on the board. I will just explain it to you. What is the logic behind this program, and I will just put some sample values in the program in order to make you understand what are the nitty-gritties into it, how it works, and the details into it. So let us just get started with the code first. Now I have beforehand I have just declared some variables, and including one integer array which is named as int a10. N is the number of bits to be entered by the user. CTR is a counter variable. I is a variable which is the loop variable, and a sum which will ultimately give us the decimal equivalent of the binary bit pattern. So this sum is now initialized to 0 beforehand. Now see, I have written how many bits. I have asked the question to the user. The user gives the number of bits in the form of n, and as soon as the user enters n, this n value will be initialized into the counter variable CTR. Now we write a prompt, printf entered the binary number, in order to prompt the user to enter the binary number for which we are going to find the equivalent in the decimal, for which we are going to find the decimal equivalent. Enter the binary number. The user enters the binary number in this way, by these two lines. For I is equal to 0, I less than n, I plus plus. This is quite easy for you to understand because it is just an input in a loop. For I is equal to 0, I less than n, I plus plus, scanf %d ai. That is, one by one the number will be, the bits will be input into the array A. So now after that we come to the logical portion, that is the calculation portion, by which we are going to calculate the decimal equivalent from the binary number. For I is equal to 0, I less than n, I plus plus, I have written if ai is equal to 1, sum is equal to sum plus pow 2 comma ctr minus 1. For incorporation of this pow function, that is the power function, we have included the math.h header file beforehand in order to get this pow function from the math.h header file. So this is the library function pow, which calculates 2 to the power whatever is the value of counter minus 1. Then the counter is decremented by unity, that is counter is decremented by 1, and the loop goes on like this. After coming out of the loop, I have printed the result because of the paucity of the space on the right hand side. I have written it in the next line. You can write it in one line. Printf, new line, the decimal equivalent is %d sum. Whatever is the result, whatever is the ultimate value of sum will get printed by this line, and that will be our output. After that, return 0 and the ending brace. Now we are going to put some sample values in order to make you understand the program. So let us put some values into it. Suppose this is the array. There is the A array, 0, 1, 2, 3, 4, etc. So suppose the user enters the number of bits to be 3. So 3 bits are to be entered by the user from the standard input device, that is the keyboard. So enter the binary number prompts the user to give the bits from the keyboard, to enter the bits from the keyboard. The user enters, suppose user enters 1 1 0 1 1 0. This is the sequence in which the user enters 3 bits. So I have to find, our objective is to find the decimal equivalent of this binary bit pattern 110. So by this programming logic, we are going to find what is the decimal equivalent, and let us see if for I is equal to 0, for I is equal to 0, less than n, yes, less than n, we come to this line if ai equals 1. Let me see, if ai equals 1, a0 is definitely 1, so this condition is satisfied. Sum is equal to sum plus power 2 comma counter minus 1. So sum is equal to 0 plus, because sum was originally 0, so sum is equal to 0 plus power 2 comma CTR minus 1. What was the value of CTR? CTR was previously n. So n minus 1, that is CTR was n, means 3. So 3 minus 1 means 2. So it is 0 plus power 2 comma 2, that is 2 to the power 2, that is 0 plus 2 to the power 2 means 4, 0 plus 4 is equal to 4. So sum becomes 4 now. Then what we have done, counter is decremented by 1, counter was 3 before and now it becomes 2, counter becomes 2. Now again I plus plus, I is equal to 1 less than 3, perfect. Again this checking if ai is equal to 1. If ai equals 1, that is if a1 equals to 1, yes, a1 is 1, and then again we do this calculation. Sum is equal to sum plus, sum is now 4, because we have got 4 over here, 4 plus pow 2 comma CTR minus 1, pow 2 comma CTR minus 1, CTR is 2 minus 1, that is 1. So 2 to the power 1, 4 plus 2 to the power 1. So this gets evaluated first. 2 to the power 1 is definitely 2, and this 4 plus 2 gives you 6. So 6 is now the sum. Now the updated value of sum is 6. Now counter is again decremented by unity, CTR minus minus means CTR is equal to now 1 from 2. Now again I is equal to 2 less than 3. If ai is equals to, if ai equals 1, let us see a2 is 0, it is not equal to 1, so we skip this calculation and go to this line CTR minus minus. So CTR becomes 0. Now increment I by 1 to get I value is equal to 3, which is definitely not less than equal to 3. Condition is not satisfied. We go out of this loop, and what is the ultimate value of sum which we have got here? We have got 6 over here. So after coming out of the loop, by printing this line, the decimal equivalent is %d, that is %d will be 6. This sum 6 will be printed. So the output will be definitely 6. That 6 is going to be printed. So this is the decimal equivalent of this binary bit pattern 110. So let us look at the look in the perspective of the binary arithmetic. Whatever we do in the binary arithmetic, let us perform that operation in order to tally both the results, whether to see if they match to each other. So I am just rubbing off a little bit, I am rubbing off this section over here in order to get some space to work on. So let us see whether the calculation matches with our output. 110 is the bit pattern entered by the user. This is the LSB, that is the 0 position. This is 1 position. This is the number 2 position, which is the MSB. This is called the most significant bit position. This is the least significant bit position, LSB. So this is the order in which it is counted. The binary number is counted from LSB to MSB. Now let us see the arithmetic, binary arithmetic behind it. In order to convert this, we see that this 0 is in the LSB. So 0 into 2 to the power 0 plus 1 into 2 to the power 1, 1 into 2 to the power this position, 0 into, because this 0 is this one, this 0 is this one. So, 0 into 2 to the power 0, 1, this 1 is this one, 2 to the power 1 means this position will be taken as the power 1 into 2 to the power 1 plus 1, again the bit is 1 and 2 to the power, this is the position 2. So, this gives you the result 0 into anything is 0 plus 1 into 2 to the power 1 means 2, 1 into 2 to the power 2 means 2 to the power 2 means 2 square means 4. So, that gives us the result 6. So, see this arithmetic, binary arithmetic yields the same result as we have got from the program. So, both the results match to each other. So, that proves that the program is correct and is ready to be run on the computer system. And if you have any doubts or queries pertaining to this program, you can well post your queries and doubts into the comment section so that I can address those doubts and queries. Thanks.